Good day, everyone. So I'm coming your way again to give solution to mathematical problem. The last video I dropped was about loss of indices, and so we want to apply it to some questions and see how these laws apply. And I've put up some questions. If you see on the left hand side there, you see some questions on the board, and I'm going to solve them one after the other, and I'll be telling you which of the laws apply to each question as we are solved them. Follow me and enjoy. So if you look at question 1, it says find the value of 4 raised to power 1 over 4 and everything raised to power 6. Can you see that? All right. If you look at this, 4 itself is 2 raised to power 2, then raised to power 1 over 4, and everything raised to power 6, right? So if you look at that, this is a case of double power, right? If that is double power, it means multiply this power with this one, it becomes 2 raised to power 2 over 4, and everything raised to power 6. Then the power inside there, you can cut this one by 2, cut this one by 2, that gives you 1 over 2. So everything now is 2 raised to power 1 over 2, then raised to power 6. This is another double power. Multiply this by this, it will give you 2 raised to power 6 over 2. 2 here 1, 2 here 3. So you have 2 raised to power 3, and your answer is 8. 2 raised to power 3 is 8. And I hope you can see how that applies. Okay, let's see the second one. There you have 125 raised to power minus 2 over 3 multiplied by 15. What do you think about this? Okay, this is a negative index. And what do I say? You put 1, write everything again as denominator, but without the negative sign, multiplied by 15. And so this will give you 15 all over 125 raised to power 2 over 3, which is the same thing as 15 over, so if you look at the denominator, this becomes fractional power. And like I said in the previous video, what the term is what the root would be. Definitely it's going to be inside root, but what the term is what the root will be is the denominator of that fractional power. So it means it's going to be cube root. You have 125 inside here and raised to power 2. All right. What is the cube root of 125? That's 5 raised to power 2. So it becomes 15 over 25. 5 here, 3. 5 here, 5. And so your answer is 3 over 5. Is that clear? Okay. So we are going to go to the next one, but I need to rub off the board. Okay, so that we have more space. I hope that is clear. You can always send in question as comments on this channel. Then you can also let me know if there is any question that is giving you problem you want me to solve for you. Number 3, what we have there again is 125 raised to power 1 over 3 multiplied by 49 raised to power 1 over 2 multiplied by 10 raised to power minus 1. Okay, so all you just need to do is to apply the laws, the one that comes to your mind. Look at what laws apply to each component of this question. All right, if you look at the first one, it's similar to what we did the other time. So this is a fractional index telling us it's going to be root. What the term is that root denominator. So it's going to be cube root of 125 multiplied by, okay, fractional index again. It tells us it's going to be root, but what? Square root, okay, 49. Then negative index. So it becomes 1 over 10. Okay, what's the cube root of 125? All right, thank you. 5 multiplied by, what's the square root of 49? 7 multiplied by 1 over 10. Okay, 1 over 1 over 1. Okay, so if you look at this, 5 here 1, 5 here 2, and your answer is 7 over 2, or 3 whole number 1 over 2. I hope that is clear. Then the next question, number 4, we are to simplify 1 over 16 raised to power minus 3 over 4 plus 5, then multiply by 1. All right, if you look at this in the brackets here, we can rewrite this expression as 16 raised to power minus 1, right? Minus 3 over 4 plus 5. That's 1. All right. So 16 itself, it's a product of 2. Okay, 2 raised to power 4 is 16. Then raised to power minus 1. Everything again raised to power minus 3 over 4 plus 5 times 1. All right. 2 raised to power 4, then minus 1, that becomes double power. This multiplied by this, it becomes 2 raised to power minus 4, raised to power minus 3 over 4. Of course, this 4 we cancel this 4, we have plus 5. Okay, minus times minus is plus, so we have 2 raised to power 3. Minus times minus is plus, so this 4 has cancelled this, so the power we have left there is 3 plus 5. 5 times 1. No big deal about the 1 there since it's multiplication. Okay. Okay, sorry, let us not be quick to add the 1, because I'm going to show you something. Because if you apply BODMAS to that question after solving the bracket, what we have left, we have addition and subtraction. We have multiplication, okay, multiplication, addition. So we can do the multiplication before addition. This 5 is added to this one, but we must take care of the multiplication, which is 5 times 1. Okay, so we are in order. If you do 5 times 1, we are in order. But you must first of all check it out. Maybe we have to add it to what we have from the bracket first before we multiply or whatever. Check the order. These days it is no longer called BODMAS. Things are changing. It's now BIDMAS, but it's still the same thing. If you follow the full principle, you should get the right answer. So this is 8 plus 5, and your answer is 13. All right, I hope that is clear. Okay, let's see how to solve the last question for the day. So I cleaned the board once again. I hope you are enjoying. I hope the explanation is clear enough. The last one now, we are to evaluate 9 raised to power 1 over 2 multiplied by 27 raised to power 2 over 3 all over 64 raised to power 2 over 3. Like I said, don't try to, guess what the answer will be before you start solving. Just look at the question and apply what you know to the questions. Okay, 9 raised to power 1 over 2. That tells me there are 2 ways of doing this actually. So you might want to say this is the same thing as 3 raised to power 2, because 9 is 3 raised to power 2 raised to power 1 over 2. Then that results to a double power, right? Then you can as well say 9 raised to power 1 over 2, which is a fractional index, right? So that means it's going to be root 9. Okay, but let's use this second method, this other method I've started with, because we have used the other one in previous example. So 27 again is 3 raised to power 3, then it becomes double power with 2 over 3, then everything over 64. Okay, you remember that 64 is 8 times 8, and 8 is 2 raised to power 3. The other 8 also is 2 raised to power 3. So 64 is 2 raised to power 6 into 2 over 3. Okay, double power, all through. 2 here can cancel 2 here, right? This is 2 over 3, pardon me. This is 2 over 3. So 3 here can cancel 3 here. Okay, 3 here, 1, 3 here, 2. So if you look at all of that, the resultant will be for this 3 multiplied by 3 raised to power 2. Then down here we have 2 times 2. Don't forget 3 here, 1, 3 in 6 is 2. Okay, so 2 times 2 is 4. So that becomes 2 raised to power 4. Okay, what we have, look at this. This becomes the product rule, right? This is 3 raised to power 1, right? So it becomes 3 raised to power 3. That is, we have added the power. Let me just indicate that for reference purpose there. right? We have that's 3 raised to power 3 over 2 raised to power 4. 3 raised to power 3 is 27, 2 raised to power 4 is 16, and that is your answer.